Greetings students, scholars, and curious viewers. This is Mr. SKT, otherwise known as the Super Kuroishi teacher. In today's lesson, we're going to be dealing with an intro as well as the first type of algebraic equations. Very often, I do this section straight after algebraic expressions. So as a result, a lot of my students ask me this question of what makes an algebraic equation different from an algebraic expression. Two things. Number one, as you can clearly see, one has an equal sign, the other does not. The first one you see there, x plus 2, just normal x plus 2. That is what we call a algebraic expression. It's just expressing a variable plus the number 2 as a number sentence. However, the second one, you notice that we have that same x plus 2, but now it's equal to 5. It could be equal to pretty much any number that you choose, but it's that equal sign that tells you that this thing has a result. It's equal to something else. That's what pushes it from expression to equation. And if you think about it, the first 4 letters of equal are in the word equation. So yeah, makes sense. The second thing is the role of the letter itself. Here I've got expression of y minus 3, and I've got the equation y minus 3 equals 6. So the role in the expression y minus 3, that y could be anything. It could be any letter. It could represent any number. As you know from your basics of algebra, a letter can be used to represent a number. And in the expression y minus 3, y could be any number that you choose. Hence why it's called a variable. But in an equation, only one number will suit the value of y to which will make that true. In this case, it'll be 9, because only 9 minus 3 will give you 6. So y can't be, so that letter y over there, it can't be any number anymore. And it's now just a value that we don't know what it is at the start when we read it. Hence why it takes the new role of an unknown. Now we go on. Now, these are the types of equations that we will be solving in the section of algebraic equations. There's the one-step equations, the ones that can be done in one step. Multi-step equations, often done in more than one step. Both side equations, when you have unknowns or variables on both sides. And exponential equations, where the unknown is the exponent. There is something though that you should know. These are not the official names of these equations, of these types of equations. These names I made up because it's easier to describe them like this. And it's something I thought it will connect with my students a lot better. Anyway, without further ado, I think it's time for us to now start actually solving for some one-step equations. So here comes our first example of x plus 2 equals 5. Looks familiar, doesn't it? So we need to solve for x. We are to solve for x. We are to figure out what number x is that will make this equation true. Yes, I know a lot of you are going to be shouting out x equals 3, and you would be right. X would equal 3. However, I'm going to show you how to actually do it, how to actually do the working. Because if you can see how it's done with the one step, then you would see how it's done for the multi and both side equations. There are two rules, not so much rules, but two sort of pieces of advice that I can give regarding solving equations. The first piece of advice: keep your unknowns on one side. Whether it be the left side or the right side, keep them all on one side. And the second piece of advice is that everything else, do like Patrick from SpongeBob. We gotta take Bikini Bottom and push it somewhere else. So in other words, keep that x over there, and that +2 you are going to move to the other side of the equation. In other words, to the right hand side. So you have only x equals, and then what happens on the other side? That 5 was already there, so that 5 is just chilling. But now here comes the most important step. If we are moving that +2 over to the right hand side. Since it's crossing an equal sign, whatever that was happening to that +2, it now does the opposite. So it was +2 on the left side, so the opposite of +2 is -2. So x equals 5 minus 2, which equals 3. And didn't we say in the beginning that we knew x was equal to 3? Well, there's the working out for it. And that's how you do a basic one-step equation. So of course addition isn't the only sign that you're going to be dealing with. You usually deal with like about 6 different ones. So let's go over let's do some more examples. Let's do y minus 15. Y minus 15 equals 7. So as I mentioned, keep the unknowns on one side. In this case, I'm going to keep y on the left hand side, which means all the numbers, I'm going to take them and push them somewhere else. I'm going to push them with the other numbers on the right hand side. And just like what happened with the first type, when something crosses the equal sign, it becomes the opposite of what it was. So that minus 15, so you get y equals, the 7 was already there, and that minus 15, the opposite of minus, is plus. I'm jumping ahead of myself over there. So that 7 plus 15, which gives you an answer of 22. And that's that one solved. Let's cover the other ones while we're here. Okay, here I'm doing 3x equals 18. So just like all the other ones, keep that x over to the other side, move that 3 over to the other side. But now we need to decide, what was that 3 doing on the left hand side, so we can work out what it's going to be doing on the right hand side. Well, 3x can otherwise be written as 3 times x. Am I correct? So if that 3 is multiplying on the left, then what's the opposite of multiplying? It's dividing. So x will be 18 divided by 3, which gives you a final answer of 6. And just to check, does 3 times 6 give you 18? Yes, it works out. All right, then let's do it. Then, of course, with multiplication out of the way, we can now do a division one. A divided by 7 gives you 4. Keep that a on the left hand side, move that 7 over to the right. So you end up with a equals 4, and then a division by 7 on the left hand side moving it to the right, the opposite of division is multiplication. So A will equal 4 times 7, which will give you 28. Now, check this one out. B squared equals, let's go with 81. Right. B squared equals 81. Keep the B on the left hand side, and you can actually move that exponent squared over there to the right hand side. Now we need to decide, so B equals, now we need to think, what is the opposite of squaring? The opposite of squaring is square rooting. So your first thought would be, well, B is the square root of 81, which indeed is correct. However, my high school children, there is one additional thing to add on. You see, only if your exponent just happens to be an even number, the answer won't just be the square root or the fourth root or whatever. It's going to be the positive and negative versions. So your answers more like are going to be plus minus the square root of 81, which is plus minus 9. Because if you think about it, if you take positive 9 and you square it, you will get 81. If you take negative 9 and you square it, you will also get 81. So it makes sense. So it indeed makes sense. But remember, this only happens, you only do the plus minus if your exponent is even. If you had an odd exponent, like for example, c to the power 3 equals 125, keep the c on the left hand side, move the 3. The opposite of, so c being raised to the 3, the opposite of being raised to the 3 is the third root. So you're finding more essentially the cube root of 125. This, you do not put them plus minus. Your answer will just be the cube root of 125, which c equals then 5. Because if you do 5 to the power 3, you will get positive 125 as like so. If you replace negative 5 over there, your answer would actually be negative 125, which is not the same as that. With odd exponents, you keep the positive and negative answers separate. Only with even exponents can you do the plus minus. And then we have one more and need to show, which is, let's see, square root of, we can do two more, like square root of x equals, let's say, 7. Square root of x equals 7. Keep the x there. You can actually move that square root over to the other side. What is the opposite of square rooting something? It's squaring something. So x equals 7 squared. 7 squared, 7 times 7, x equals 49. And this works with any other root. If you had, for example, even the fourth root of k, because why not? And that equals 3. It's the first number that came to my head. So the fourth root of k equals 3. Move that fourth root over to the other side. It's all about isolating that variable, that unknown. I keep using variable because it's like ingrained into my language. But anyway, keep that letter on the left hand side, or if it's on the right, keep on the right, whichever. It doesn't matter. Whichever. It doesn't matter, because the whole thing is that equations are meant to balance. The left hand side is meant to equal the right hand side. So as long as you have all your variables on one side, then it doesn't matter where it's the left or the right, actually. Anyway, I've been babbling. Keep the x and keep the k on the left hand side. Move that fourth root. The opposite of fourth root is raising to the 4. And 3 to the power 4 is 3 times 3 times 3 times 3, which is 81. And that there, students, is our demonstration of what happens for solving for one-step equations. Now I've written you a little custom exercise for you to do. I'm going to slowly scroll through this. This should give you opportunity to take it down as we go along. All right, and now of course the full screen. Oh, there we go. Right, if you wish to do this exercise by yourself, this is the time for you to pause the video. Pause video in 3, 2, 1. That was too uncanny. I did not mean that, by the way. Anyway, now with that done, let us do the correction. The first one, x plus 10 equals 14. Keep the x on the left hand side, take the 10 over. When the 10 moves across the equal sign, the opposite of plus 10 is minus 10. So x equals 14 minus 10, which is 4. Done. A minus 8 equals 13. Move the minus 8 over to the other side. So A equals 13 plus 8, which is 21. Number 3, 2y equals 22. Move the 2 over to the other side. That 2 is being multiplied by the y. So moving the 2 over, the opposite of multiplication is division. So y equals 22 divided by 2, which is 11. B divided by 5. Oh my god, I made such nice arrows all up to here. Bah. So b divided by 5 equals 15. Keep the b on the left hand side, move the 5 over. Division by 5 on one side becomes multiplication by 5 on the other. So b equals 75. And as a way of checking, 75 divided by 5, yes, it should give you 15. Number 5, x squared equals 49. So take the square sign over. It is an even exponent, so you should be writing x equals plus minus the square root of 49, which will give you plus minus 7. Because positive 7 squared will give you 49, and negative 7 squared would also give you 49. The square root of y equals 6. Move the square root over. So that means y equals the opposite of square root is squaring. So y equals 6 squared, which is 36. Number 7, 2 over 3 times b equals 18. Keep that b over on the left hand side. That 2 over 3 is multiplying by the b. So when you move it over to the right hand side, the opposite of multiplication is division. Even though the multiplying sign is happening before the b, it's not always about what's before the thing that you're moving. It's what it's doing. Even because that would be like a positive 2 over 3, but that 2 over 3 is multiplying by the b, so that's why when you move it, it's not, you're going to be doing the opposite of multiplication, which in this case, b equals 18 divided by 2 over 3, which gives you 27. and then finally, x to the power of 3 equals 1000. Take the exponent 3 over to the right hand side. The opposite of exponent 3 is root 3, third root, cube root. So x is the cube root of 1000, which is 10. And that is our first lesson of algebraic equations dealing with one-step equations. If you enjoyed this content, please leave a like, share and subscribe, share with your friends, and please subscribe, and also comment on what you would like to see next. With that being said, have a nice day.